Hi, this is Tim. In our last video, we uploaded the program from our Allen Bradley CR30 Safety PLC to our PC. And in this lesson, we're going to take some time just to go through it and really let's just talk about what it actually does. So again, as I've stressed before, our goal here is not to understand how to design safety circuits. Our goal is to understand how to troubleshoot them when they don't work. Because obviously, even right now, I have a flashing red light. So if we go into the program, can we figure out how? Also, can we figure out how just by looking at it? Because those are two important tools. But all right, so we had uploaded, and right here we see this edit logic button. And let's go ahead and press it. And here is our program. Now this program does not look anything like the ladder logic that we were used to seeing. This is a type of function block programming. It is a very rigid program. It has fixed, it actually, even in function blocks, usually you can drag something here or there. This is very fixed. It's designed to be well planned out and well executed. But we can learn a lot just by looking at this. So here, our first thing, it says safety monitoring. And we see we have an e-stop panel, okay? And it says EI00 and EI01. If you notice in our wiring enough to get started exercise, we wired switch 3, which is the first red mushroom button, to inputs 0 and 1 on our safety PLC. And here they are right here, EI00 and EI01. Now, we didn't wire the other side of these like we traditionally would to the plus 24 volt. We wired them to 12 and 13. And if you see right here, this test source A and test source B, that is the 12 and 13. And if we open up our advanced options, we're going to see that, all right, it tells it right here that we are using two normally closed contacts and we are doing pulse testing. And so what it is doing is it is testing through pulsing that the circuit is good off of 12 and 13 through our set of contact blocks and two inputs 0 and 1. And in a later video, we're actually going to really look at what is this pulse testing and what does it actually do. But okay, so this one does look nice and green. Now, if you left yours exactly like I did in the video from the Getting Started guide, you'll remember that I pressed switch 4 at the end of it. So if we scroll down, this one right here is switch 3. Right here is that switch 4. So first we see our test source A, 12 and 13 are exactly the same. And that's why we were able to jumper the left contact on both of switch 3 and switch 4 and the right contact on switch 3 and switch 4. But notice that this one is not green like this one. So let's go ahead and pull switch 4 out here. And immediately this turns green. And yes, in this case, again, let's be really cautious with our words. But in this case, green is good. So now let's follow it up. So we have a green wire now. And all right, and before this was not green. And so this is an and symbol. So what this is saying that this condition and this condition must be true or must be green before it's going to pass it on. So let's press switch 4 again. And all right, now we can see this bottom one has turned gray. We still have green at the top, but no, we're not getting green through. We can pull switch 4 out and press switch 3. And now the opposite is true. We have green coming up from this bottom one. But we're gray here, so we're gray here, and we're gray on through. We'll pull that back out. Okay, so now green, green. So we have green and green. It passes green on through. And then we get to this block right here, which looks a little confusing maybe at first, but literally that's all it is a pass-through block. It's just a blank block that wasn't needed because this is a very structured grid. You do have to have something here. And in later videos, we'll create some programs. Right now, we just want to understand. So now we get to the safety outputs. And really, here's where we're always at. It's like, I think the e-stops are out. Everything looks good. But our output is not turning on. And so this is a really important thing to understand exactly what is going on here. So first, let's just press switch 4 again. And all right, everything is definitely solid gray. We pull it out. Now we're getting green. We got green, and we're getting flashing green and gray over here. And what that means is the conditions leading up to this are true. But we have a reset here that needs to be pressed. And this says SMF17. And good grief, how would you ever find SMF17? Well, if you go back over to your left side, you're going to notice this first one's SMF1. And if we go to the next one, it's SMF2. And then we can go down to SMF3, 4, 5, 6, 7. So it is a true grid structure. And if we go down and we skip on down past these, you're going to find 17 down here. And it is the 17th one down. And so it says that EI-10 is the reset. And if we look at our diagrams, to terminal 10 at the top of our CR30, we wired our blue button. So if we go back up to the top and we go over to where we're seeing the flashing green and gray, when we press button 4, they are going to turn green, and also it was signified for green light. So now our relays are on. When we press switch 4, they turn gray, they are off. We pull it back out, they are flashing green and gray, and the relay is not on because it needs reset. And we can look right here to figure out where we need to reset it. So we'll hit the blue button. Oh, and there was another little thing there that I really didn't talk about. And I'm gonna save it mostly for another video, but let's make one other observation just while we're here. Let's press switch 4 again. We'll pull it back out and press the blue button, but don't let off of it. Now notice our blue light is still flashing and our green light is not on, and our relay is not resetting. It requires you press it and let it back off within a certain amount of time. So remember that one for later, because right now I've been holding it while I'm talking. I let off, and yeah, it's not going to reset. But if we just press and release, it resets perfectly. So save that one for a little later here. We have this pass-through block. It went to relay 1. Is there anything else important to talk about here? Oh yeah, the feedback. So we haven't talked about that yet. So we've talked about there is a reset here, and there's the reset input. Is there also is a feedback. So everything as far as a safety output usually will have some type of monitoring coming back. Where's the feedback at? It says SMF3. And if you remember from our SMF17, that means we're going to be on the 3rd row down. So let's go back over here. We'll find number 3, and there it is. So in this case, we are looking at P2-00. So where is that? Well, P is our plug-in module. It is the second plug-in module, and it's input number 0. So input number 0, if you recall, looped in series with our safety relay number 1 and safety relay number 2. So and then it comes back, and that's how we're monitoring that those safety relays are switching on and off. So let's go back up, and we'll go back over to where we were on the top row. So SMF3 is what that is monitoring. Okay, so that covers the monitoring, but we hadn't actually talked about the output of this. So the output of this is right here, MP 14 and 15. Now MP is for multi-purpose, and so they can be configured for many different things. In this case, we are configured them as safety outputs, and 14 is going to safety relay 1, 15 is going to safety relay 2. This right here is going to energize both of these relays, and then it's going to look for feedback off of it on SMF3. And in later videos, we're going to talk about what's it look like when they're broke. And then whenever there's a reason, such as I need to stop pressed, pull back out, it does need to be manually reset. And right now that is the blue button. So now we have a branch going down. This one right here is for our PowerFlex drive. So again, we have two outputs on it. And if you recall, we connected S1 of the PowerFlex 525 drive to terminal number 16 and S2 to terminal number 17. And that is what's giving it it's safe to run. And then again, we're going to have a feedback here. So this feedback is SMF4. So we go down now to the fourth row down, and there is our VFD. And it is going to connect to plug-in module, slot 2, and it's going to be input number 1. So if you recall, we connected 24 volt to R1, and R2 is coming off and going there. And that is telling it, all right, it's switched on and it says the drive is ready. So they're going to be monitoring every time that one of those relays or drive is given a signal that it's okay to run. It's going to monitor to make sure it's switched. And when it turns it off, it's going to monitor it to make sure that it turned off. And in later videos, like I said, we're going to talk about what happens when things don't work perfectly. So that really covers the safety portion of this drive. But we still have some more blocks down here. So what do these do? Well, this is an important part that I think, well, actually there's two important parts that are left out of safety, and this is one of them, is we can signal what is going on to an extent. Now, hopefully you have an HMI. We're going to add an HMI to this trainer later and talk about how we can read, you know, the state of everything on it and signal. But right now we don't have an HMI. So we need to tell people what is going on here. So first, this is looking at the output loop of SOF1. So let's go up and let's find SOF01. Of course, 1 is this first row. And if we go over here, there is our SOF1. So if this is green or everything's good, mainly we're not gray, we're not flashing gray, we are actually green, then this SMF5 is also going to be green. So let's press now that we're on it, switch 4. See, immediately that dropped out. Pull it back out. So now up there, it is flashing green, but here we're not, because all it's looking for, it just wants good or bad. That's all it knows. Press here, and now we're good. So then we have this SMF6, and it's looking at SOF02. I know it's a lot of acronyms, guys, and honestly, I got to learn them too. But we go up to mainly row number 2. Then we go over and we find the SOF, and there is 2. And again, it looks good and green, so that means that we're good and green down here. So if we didn't see it, that would mean either our feedback is bad or the conditions before it are not true. But all right, so we are good here. So now we're saying, okay, if our loop off of our 2 safety relays are good and the loop through our drive is good, then there again, there's one of our pass-through blocks. And then we see, we even named this one to make it a little easier, is it says status out green light. And then it says P200. And that means plug-in module, number 2, and it outputs 0. And if you recall, in our wiring diagram, we wired that to our green light. So that's how we get our green light on, signaling that everything is good. So next, let's go to the next rung. This one says standard signal. And yeah, I see a plug-in module 202. So I don't think we ran into this one yet. But so plug-in module number 2, input 2, if we look back at our wiring diagrams, it's wired to our yellow light. So what happens then when we press our yellow button? Our yellow light is going to come on. So let's talk about how. So again, this is just looking standard signal. Is it on? Is it off? Now in this case, we do have an input filter that we're not using. and we'll probably play with it a little bit later also. But then we have a pass-through block, and again, a pass-through block, if it's gray coming in, it'll be gray going out. If it's green going in, it'll be green going out. So we got green through there, we got green through the next one, and then again, we have one of these status outputs, and this is status out yellow light. Now, when we press it, we see it's green, we let off, it's gray, and it's going to P201. So that is plug-in module number 2, output 1, which yes, on our wiring diagram is wired to our yellow light. Okay, let's look at the next one down now. And all right, so we have those output loops again. Now these are poorly labeled. Now, we'll talk about later in videos how we could label these better. I've labeled most of this at the default just so we could see what it would look like. But all right, so this one says output loop number 3, but okay, mainly it's looking at SOF1, and isn't that the same one that the green light was looking at? Let's see. Yeah, it is. So this is the exact same thing as our green light. And then we look down here, actually the next one down says SOF4, which is the exact same thing that our green light was doing. Okay, we have a third condition now. And what is this third condition? It's looking at SOF01. So where's SOF01? What is it? Oh, we're back to those relays again. So this is looking, are our relays energized? So now we'll go back down. Let's make sure we keep track here. So then we have a NOR. So we've talked about the AND, we've talked about the OR. A NOR says that none of these conditions can be true. So our relays cannot be energized. Our PowerFlex drive cannot be energized. And then we have a third condition down here. And okay, this looks almost the same as this first condition, because we're saying that, okay, look and see if SOF01 is on. Well, this one looks to do the same thing, but there's another note down here of type. But it's not real clear here what this SOFRR is. Now it's clearer, and here's where I kind of wish they'd add a little mouse over some descriptions, or I guess in time you just learn these, is when we're offline, it actually gives us a little more info. So let's go over, now first, how do we even go offline? I don't think we've actually talked about that, because really we've uploaded our program and that's kind of where we've been. Let's go back to our GuardMaster 440C-CR30 tab. And then here it says connected. Let's hit the drop down, and right there we're going to go offline. And now we're going to go right back to that logic tab, and it still says SOFRR, but when we click on it now, we see SOF reset required. So what this NOR is saying is that, one, the SOF01, which are our 2 safety relays, is not energized. NOR is our SOF02, which energizes our drive, nor do we need to hit the reset button. So now let's go back online where we can see the greens and make sure we understand exactly how that's working. So now we'll go back to that GuardMaster tab, and where it says disconnected, we're going to hit the drop down. Again, we just want to connect to the device. We don't need to upload. We don't need to download at this point. So we're going to connect to device. And then we're going to navigate back to our PLC. Okay. And now let's go back to our GuardMaster tab. Let's scroll back down to that NOR so that we can see it. So right now it's saying, okay, output loop 1 can't be on, or output loop 2. Well, there's 2 strikes against it. It only needs 1 strike with a NOR. So if any of these are green, the NOR is not going to let true conditions or green through. So let's go ahead and let's drop these output loops out, which all we got to do is hit switch 4. And there you go. Immediately, all right, now we have all gray coming through here. And since we have gray, 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 and this is a NOR statement, it actually is going to put green out on the other side. Now, this can be a difficult concept, especially if you're coming straight up from ladder. is this NOR statement right here. So if any of these were green, this would be gray. But all right, let's pass it on through. Then we'll revisit this in just a second, but let's see what it does next. Next, we have a pass through. Okay, and now we have something that is flashing on and off. And it says status out to, and it is going to P202. So that means plug-in module number 2, output 2. And according to our wiring diagrams, we have that wired to the red light. And so why is it flashing? Well, one of the very convenient features, since usually we're just trying to flag something, is this pulse signal. If this is selected to a on state, it is going to pulse on and off. Now let's scroll back up to either one of these. Let's just scroll right up to light 2 so that we can see. See, this one, the pulse was off. So when we press the yellow button, then the yellow light is on solid. But down here, we kind of want to signal somebody, hey, you need to look here. Something's wrong. We can use this pulse signal to do that. All right, so let's just nail down this NOR just a little bit more here. Scroll where we can see the bulk of it. Okay, so right now our NOR is good. Now, what I want to do is I want to pull switch 4 out, but we're not going to reset it. Okay, and you see immediately this went gray. And the reason it went gray is because we ended up with one green here. So any green here on a NOR will mean gray coming out the other side. So if we had 2 greens, we'd still be gray. If we have all 3 greens, we're going to be gray. But mainly in this case, we're wanting to signal that if our output loops are not on and we don't need reset, we need to turn the red light off because something's wrong out there. But now we don't want to because we're clear and we need to signal, hey, we just need a reset. So how are we doing that? Well, let's scroll down a little more and here we go. So here is another status in, and we're looking at that same SOF01 that we looked at so many times. So it's saying, okay, is the SOF good and does it need reset? And currently it does need reset. So let's scroll up to the very top so we can see that. And see, it's flashing green. And that means, yes, we need our reset input. So if we go back down, that is making this green. We have another pass through, and again, pass throughs, if they're green in, they're green out. If they're gray in, they're gray out. And we have a status out going to P203. So that's plug-in module number 2, output 3, which we have wired to our blue light. And that is why our blue light's flashing. So with these few extra lines of code, not only are we being safe, now I'm going to put that in big quotes because evaluating whether a system is safe or not is a very involved process, and that's not the point of this series. But with those few rungs underneath it, we've been able to say right now, all of our safety devices are in the proper position to run, but we are awaiting a reset. Or once we hit our reset, we were able to say we're green, we are ready to roll. Or we're red, flashing so that we see, hey, we need to do something over here. So there's a little dip into how this program works. And in future videos, we're going to keep going through it and keep talking about some of the interesting features. And eventually we're going to program some of our own safety circuits just so we can understand kind of how to work with the program and software. So again, please hit that like button and subscribe to our channel. Till next time.
Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!